There is no blanket requirement in the National Electrical Code for a pull box or junction box after a specific number of feet of conduit in a straight run. The need for pull boxes is determined by the bending degrees within a conduit run and the difficulty of pulling conductors. The NEC addresses conduit fill, conductor sizing, and pull box sizing, but not a maximum length for straight conduit runs. The primary concern is ensuring that conductors can be installed and maintained without damage. Section 314.16 covers the requirements for calculating the size of pull and junction boxes. This section details how to determine the minimum dimensions of boxes based on the number and size of conductors entering and exiting the box. For straight pulls, 314.16 subsection A 1 specifies that the length of the pull box shall not be less than 8 times the trade diameter of the largest raceway. For ankle or U-pulls or splices, 314.16 subsection A 2 provides more complex calculations based on the raceway sizes and the distances to the opposite wall of the box. These calculations ensure adequate space for bending conductors without exceeding their bending radius. Article 300 addresses wiring methods and materials, including the installation of raceways. Section 300.14 discusses the length of free conductors at outlets, junctions, and switch points, ensuring sufficient wire length for making connections and future modifications. Section 300.18 covers raceway installation, requiring complete raceway systems to be installed before pulling in conductors. This helps prevent damage to conductors during installation. Article 310 provides guidelines for conductors for general wiring. This article covers conductor ampacity, insulation types, and installation requirements. Conductors must be suitable for the voltage, temperature, and environmental conditions of the installation. Section 310.15 details ampacity tables and adjustment factors for conductors based on temperature and the number of current carrying conductors in a raceway or cable. These adjustment factors are crucial for preventing overheating and ensuring the safe operation of electrical systems. When installing conductors in conduit, it is essential to consider the fill capacity of the conduit. NEC Chapter 9, Table 1 provides the maximum percentage of conduit fill permitted for various types of raceways. Overfilling a conduit can make it difficult to pull conductors and can lead to overheating and damage to the conductors. The NEC does not specify a limit on the length of a straight conduit run. However, practical considerations often dictate the placement of pull boxes. Long runs of conduit increase the pulling tension on conductors, which can damage the insulation. The force required to pull conductors through a conduit run depends on several factors, including the number of bends, the type of conductors, and the lubricant used. In situations where long runs of conduit are necessary, it is advisable to use pulling lubricants to reduce friction. These lubricants are specifically designed to minimize damage to conductors during installation. The use of proper pulling techniques is also crucial. This includes using appropriately sized pulling equipment, such as fish tapes or pulling ropes, and ensuring that the conduit is securely supported to prevent it from moving during the pulling process. The NEC provides guidelines for supporting raceways to ensure they are mechanically secure. Section 314.23 outlines the requirements for supporting boxes and conduit bodies, including the maximum spacing between supports. Proper support prevents the raceway from sagging or becoming damaged, which can compromise the integrity of the electrical system. In addition to the NEC, local codes and regulations may impose additional requirements for the installation of electrical systems. It is essential to consult with local authorities to ensure compliance with all applicable codes. Local codes may have specific requirements for the placement of pull boxes based on local conditions or practices. When determining the need for pull boxes, consider the following factors. Firstly, the total number of bends in a conduit run. The NEC limits the total number of bends to 360 degrees between pull points. This includes all bends, offsets, and other changes in direction. Secondly, the length of the conduit run. Longer runs of conduit increase the pulling tension on conductors. Thirdly, the size and type of conductors being installed. Larger conductors and conductors with certain insulation types require more pulling force. Fourthly, the presence of any obstructions or difficult to access areas. These factors can make it more difficult to pull conductors and may necessitate the use of pull boxes. Consider using intermediate pull points to reduce the pulling tension on the conductors, especially in long runs or runs with numerous bends. These intermediate pull points can be strategically located to break up the run into shorter, more manageable sections. In summary, while the NEC does not mandate a specific distance for pull boxes in straight runs of PVC conduit, practical considerations related to pulling tension, conductor size, and the number of bends often dictate their necessity. Always consult the NEC and local codes to ensure compliance with all applicable requirements. Always consider using pulling lubricants, proper pulling techniques, and appropriately sized pulling equipment to minimize the risk of damage to conductors during installation. It is important to note that the absence of a specific distance requirement in the NEC does not mean that pull boxes are unnecessary. The decision to install pull boxes should be based on a careful assessment of the factors mentioned earlier to ensure a safe and efficient installation. If there is any doubt about the need for pull boxes, it is always best to err on the side of caution and install them. This will help to ensure that conductors can be installed and maintained without damage and that the electrical system operates safely and reliably. When selecting pull boxes, it is important to choose boxes that are appropriately sized for the conductors being installed. The box must be large enough to accommodate the conductors and any splices or terminations without overcrowding. Overcrowded boxes can lead to overheating and can make it difficult to access the conductors for maintenance or troubleshooting. The NEC provides guidelines for calculating the minimum size of pull boxes based on the number and size of conductors. These guidelines should be carefully followed to ensure that the boxes are adequately sized. In addition to size, the type of pull box is also important. Pull boxes are available in a variety of materials, including metal and non-metallic options. The choice of material depends on the application and the environmental conditions. For example, in corrosive environments, non-metallic pull boxes may be preferred to prevent corrosion. Metal pull boxes may be required in certain applications to provide grounding or shielding. It is crucial to select pull boxes that are suitable for the specific application and that comply with all applicable codes and standards. Proper installation of pull boxes is essential to ensure their effectiveness. The boxes must be securely mounted and supported to prevent them from moving or becoming damaged. The covers must be properly installed to protect the conductors from the environment. All connections must be made in accordance with the NEC and local codes. Improperly installed pull boxes can create hazards and can compromise the integrity of the electrical system. Regular inspection and maintenance of pull boxes are also important. The boxes should be inspected periodically to ensure that they are in good condition and that there are no signs of damage or corrosion. The covers should be checked to ensure that they are properly installed and that there are no gaps or openings. Any problems should be corrected promptly to prevent them from escalating into more serious issues. Maintaining pull boxes in good condition helps to ensure the safe and reliable operation of the electrical system. In addition to the NEC and local codes, there are also industry standards that provide guidance on the installation and maintenance of electrical systems. These standards, such as those published by the Institute of Electrical and Electronics Engineers and the National Fire Protection Association, offer best practices and recommendations for ensuring the safety and reliability of electrical installations. Following these standards can help to improve the quality of electrical work and reduce the risk of accidents and injuries. Continuous education and training are essential for electricians and electrical contractors. Staying up to date on the latest codes, standards, and technologies is crucial for providing safe and efficient electrical services. Attending workshops, seminars, and online courses can help to expand knowledge and skills and to maintain professional competence. Investing in education and training is a wise investment that can pay off in the form of improved job performance, increased safety, and enhanced career opportunities. Consider the type of wire or cable being used. Some types of wire or cable require more pulling force than others. For example, stranded conductors are generally easier to pull than solid conductors. Similarly, conductors with certain insulation types may require more pulling force. It's crucial to consult the manufacturer's specifications for the wire or cable being used to determine the recommended pulling tension. When using pulling lubricants, it's important to select a lubricant that is compatible with the conductor insulation. Some lubricants can damage certain types of insulation, leading to premature failure. The lubricant should be applied evenly to the conductors before they are pulled into the conduit. Over-lubrication can make it difficult to grip the conductors, while under-lubrication can increase friction and pulling tension. Ensure the pulling equipment is in good condition and properly sized for the job. Using undersized or damaged equipment can increase the risk of injury or damage to the conductors. Regularly inspect the pulling equipment to ensure that it is functioning properly and that all safety features are in place. Prior to pulling the conductors, clean the inside of the conduit to remove any debris or obstructions. This can help to reduce friction and pulling tension. Use a conduit brush or vacuum to remove any dirt, dust, or other contaminants from the conduit. Before starting the pull, ensure that all personnel involved are properly trained and understand the pulling procedure. Clear communication is essential to ensure that the pull is performed safely and efficiently. Designate a person to oversee the pull and to coordinate the efforts of the team. After the conductors have been pulled into the conduit, inspect them for any signs of damage. If any damage is found, the conductors must be replaced before the system is energized. Damaged conductors can pose a serious safety hazard and can lead to equipment failure. Consider the environmental conditions when determining the need for pull boxes. In harsh environments, such as those with extreme temperatures or high humidity, it may be necessary to install pull boxes more frequently to facilitate maintenance and repairs. The environmental conditions can affect the performance and lifespan of electrical components, so it's important to take them into account when designing and installing electrical systems. Section 300.11 of the NEC addresses securing and supporting wiring methods. Raceways, cable assemblies, boxes, cabinets, and fittings must be securely fastened in place. Support wires that are independent from the raceway must not be used as a means of support.